So let's look at section 2.6, exercise 36. Doing that because we see this thing called adiabatic, adiabatic or badic expansion. Yes, I have no idea what that is. So we learned something here. It says when a certain polyatomic gas undergoes adiabatic expansion, whatever that is, we'll soon see, I hope, its pressure P and volume V satisfy the equation PV to the 1.3 equals K, where the K is a constant. So that's interesting. That is similar to the ideal gas law, I guess. Ideal gas law is PV equals nRT. And so if you kept N, well, N I think is a constant, maybe. R and T, temperature, T is temperature. R, I don't know, I don't remember. I'd have to look that up. I just remember that it was PV equals nRT. So this has a PV to the 1.3 instead of P times V. But K is a constant. It says find the relationship between the related rates dP dt and dV dt. Yeah, we can do that. Okay, so we're told that P times V to the 1.3 is equal to a constant K. So now if I take the derivative of both sides, PV 1.3 with respect to T equals derivative of K with respect to T. Well, K is a constant, so that's 0, but on the left-hand side, well, we have a product rule, so dP dt times V to the 1.3 plus P times the derivative of V to the 1.3 with respect to T is equal to 0. So nothing more to do here, that's just dP dt, so we have dP dt, V to the 1.3 is equal to P. But now here, see, we have a chain rule to do because we can bring down the 1.3 for the V to the 0.3 after we subtract 1, but then times, this is a plus, times dV dt equals 0. So now we can get our relationship. I don't know, which one we should solve for in terms of the other. Let's solve for dV dt, I guess. So we have 1.3 P V to the 0.3 dV dt is equal to minus V to the 1.3 dP dt. So now if I solve for dV dt, we have dV, probably should have solved for dP dt, then I wouldn't have to get 1 over 1.3, but so when we do that, we have 1 over 1.3 P minus, because of that minus up there. Then we have V to the 1.3 divided by 0.3. Well, that's just V. And then dP dt. So whatever the reciprocal of 1.3 is, let's go check that. Go here, and 1 divided by 1.3, 0.769, I'll call it 0.77. So we end up with dV dt is equal to minus 0.77 V over P dp dt. And so it is kind of interesting. Another way to write this would be if we divided both sides by dp dt, so you'd have, you know, sort of v prime over p prime is equal to minus 0.77 v over p. So kind of take a little more than 3/4 of the volume over the pressure and make it negative, and you get that ratio. So that's interesting. So that is number 36, although I still don't know what adiabatic expansion is.